In this video, we are going to learn how to write in vertex form by completing the square. Now, it's tricky to write in vertex form with the technique complete the square because we can't just move all of our constants to the other side of the equation because of this y. But it's just one minor alteration, and it's basically the same technique. So we're going to rewrite each equation in vertex form, and we're going to name the vertex and the y-intercept. So usually when we write something from standard form to vertex form, we use the x equals negative b over 2a formula, and we find the x, and then we plug in to find the y, and that helps us put it into vertex form. But if you can master the complete and the square technique to put it into that form, it'll take a lot less steps. So in order to do this, we need to actually complete the square while keeping everything on the same side of the equation. So the way this can be done is I need to imagine the negative 6 like I've added it to the other side, but instead of doing that, I'm going to just isolate the x squared plus 4x, that part that I need to get by itself to complete the square, in its own parentheses. And I'll complete the square here. And whatever I add on the inside, I'll also have to subtract on the outside, so that I keep the equation balanced. So in order to complete the square, that b value is 4. So I need to add b over 2 squared. So that's 4 over 2 squared, which is 2 squared, which equals 4. So if I add that to my x squared plus 4x, I'll need to subtract it as well. The reason why I'm adding and also subtracting is that's 4 minus 4, meaning I've essentially added 0 to the equation. So it's still the same as the original expression. But now when I factor this factor this perfect square trinomial, I will have x plus 2 squared, and just to double check again, x squared is x squared, 2 squared is 4, and then x times 2 is 2x, and twice of that is 4x. So that is how it factors. Then I'll have negative 6 minus 4, which is minus 10, and there you go, I am in vertex form. So it would have taken several steps. The other method is now only taking us 2 steps in this method. But now my vertex is negative 2, negative 10, because again, it's h comma k. It's usually x minus h, because you use the opposite value when you're getting h. And my y-intercept, well, I didn't need it in vertex form to figure this one out, because that's actually what standard form is great for. That minus 6 is the y-intercept. So x0, negative 6 is the y-intercept. So all three of these are my solution to the problem. But let's try this again. Now let's look at a situation here. So you have x squared, y is equal to x squared plus 3x minus 6. So in order to complete the square, I'm going to isolate that x squared plus 3x. So I'll have y is equal to x squared plus 3x. I'm going to leave a little space so I have room to complete the square. And then minus 6. And now I need to add b over 2 squared. So I have 3 over 2 squared, which is equal to 9/4. So I'll add 9/4 on the inside, but then I won't add 9/4 on the outside. I'll actually subtract 9/4 on the outside. So when I go to factor this, I'll have x plus, again, it's that b over 2, so 3 over 2 squared. And again, just to double check, the way I always find this number is I just take half the b value and put it there. But to double check, x squared is x squared, 3 halves squared is 9/4, and then x times 3 halves is 3 halves x. Twice of that is 3x. And here I have negative 6 minus 9/4, so I'm going to need a common denominator. So that's like 24/4. That's equal to 6. And then minus 9/4, which gives me y is equal to x plus 3 halves squared minus 24 minus 9, which is 33/4. So there's my vertex form. Even with all those fractions, that wasn't so bad. And then my vertex will be negative 3 halves, comma, negative 33 fourths, and my y-intercept is 0, comma, not negative 33 fourths, but 0, comma, negative 6. And those are my answers for that problem. So really the key is that whenever I add something, I need to also subtract it. So whatever I'm putting in here, I need to do the opposite over here. Now, this becomes a little more tricky whenever there's a coefficient involved, because now I can't just divide everything by 2 in order to do this one, but I still need it to look like x squared plus bx. So here's how you handle this situation. It starts out the same as the last two. We'll isolate the 2x squared minus 8x from the 1. But now instead of just dividing each side of my equation by 2, I'm actually just going to factor out 2. It's very similar to that division. But now I have y is equal to 2 times x squared minus 4x. I'm going to leave that space so I can complete the square because now it's in that form. Plus 1. And to complete the square, I need to find half of b, which is negative 4 there. So negative 4, half of that squared would be negative 2 squared, which is 4. So I'll add 4 on the inside. But now I don't just subtract 4 on the outside, because right now this 4 I added wasn't just 4. It was 4 times 2. So imagine that this 2 is redistributed. That would have been 2 times 4, which is 8. So I've really added 8 there, so I need to subtract 8 on the outside. Again, that comes from 2 times 4. So that 4 I added times that 2. So now when I finish completing the square, or finish factoring my perfect square trinomial, I'll have x minus 2 squared. Again, to double check, x squared is x squared, negative 2 squared is 4, and then x times negative 2 is negative 2x, twice of which is negative 4x. Then on the outside I have 1 minus 8, which is negative 7. And so there's my vertex form. And my vertex will be 2, comma, negative 7. And my y-intercept will be 0, comma, 1 from my standard form. Now the last one, now if that leading coefficient is a negative, you got to also look out for that negative coefficient in front of it, but it operates just like this too. And let me show you. So I'm going to factor out a negative from these two terms. So first I'll isolate them, then factor out the negative. So I have y is equal to negative of x squared minus 4x. Leave that space, minus 1. And half of negative 4 squared would be negative 2 squared, which is 4. So I'm going to add 4. But now I've added 4 here, but I've really added a negative 4. So that's a negative 4 I put into the equation, so I need to add 4 on the outside. And again, that's very similar to saying minus negative 1 times 4, because that's what's going on right here. So I've added a negative 4 on the inside, so I need to add 4 on the outside because of that negative in the front. Again, the best way to visualize why I'm doing this is just imagine I redistributed that negative, and that would have been a negative 4. So I need to add 4 to cancel that out. So to finish this problem, I'll have y is equal to negative of x minus 2 squared, double checking, squaring x gives me x squared, squaring negative 2 gives me 4. Then negative 2 times x is negative 2x, twice of which is negative 4x. And then I have negative 1 plus 4, which is plus 3. So there's my vertex form. And my vertex will be 2, comma 3. And my y-intercept will be 0, comma, negative 1. And if you're wondering why I found the vertex and the y-intercept, if you remember our graphing lesson, as long as I have the vertex and the y-intercept, I can easily reflect that point across the axis of symmetry and easily graph the quadratic. And that is how you write in vertex form by completing the square.